Hey guys, this is MathCamp321 and this is a lesson on Introduction to Limits in 9 examples. So the intention of this video is just to give you some basic foundation material on how to approach limit questions. There's a lot of different ways to look at limits, and this particular lesson deals with a graphical perspective. Let's get started. Consider a function f of x and its graph. Now consider a specific x value along the x-axis. A limit question will ask, what are the y values tending toward as you approach the specified x value from both the left and the right side? Let's take a look. In example 1, we're given a function f of x equals x minus 2 quantity squared plus 1. From pre-calculus or algebra 2, you should know that this is a parabola that is shifted 2 units to the right and 1 unit up. This question says find the limit of that parabola, or the limit of f of x, as x approaches 4. This little statement down here below the limit question tells us where along the x-axis I'm going to look. So I'm going to find x equals 4. And now what I like to do is I like to look to see where the curve is by looking either above x equals 4 or below. In this case, there's nothing going on below, so I'm going to look up. And sometimes I even like to draw a little arrow to point to where I'm looking. Okay, now if we read the portion of the sentence in quotes, it says, what are the y values tending toward as you approach the specified x value from both the left and the right? So let's jump a little bit to the left on the curve and let's approach that arrowhead from the left. Now right now, if we look over at the y-axis, I'm at a y value of 2. But as I get closer and closer to that x value of 4, the y values are climbing and they're climbing and they're climbing, and let's stop. Now if we look at the y-axis now, we can see about where we're stopping. Let's do the same idea, but this time let's jump along the curve, but this time to the right side. Now I'm even with about 7 on the y-axis. Now let's move closer to that x equals 4 by moving along the curve closer to it. And the y values are dropping, and they're dropping, and they're dropping, and they're dropping, and they're dropping. So these y values have dropped into here, and these y values have risen into here. And if I project over, the best, most logical answer seems to be that the limit from the left or the right is approaching the number 5. So the answer to this limit question is 5. Okay, in our second example, they say f of x equals the cosine of 2x. And I give you that graph down below. And they want us to find the limit of that cosine graph as x approaches pi over 6. So pi over 6 is going to be that spot on the x-axis that I'm going to focus on. Now, I couldn't actually find the pi symbol, so I just wrote out the word pi over 6. So pi over 6 actually happens down here. So I'm going to highlight that. And once again, like the previous problem, I'm going to look above and I'm going to look below to draw my arrow. And in this case, there's nothing happening below, but there is something happening above. So I'll draw the arrow like I did in example 1. And now I'll see what happens to the y values as I approach that x value from both the left and the right. So I'm going to jump a little bit to the left, and right now I'm even with 1, and then I'm going to drop, 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 and it looks like I'm ending up about at where this point is, which is pi over 6 1/2. The answer is sort of revealed right here. But I'm not done yet because I also have to approach from the right-hand side to make sure it's going to the same place. So I jump out, and now I start reapproaching that same arrowhead, but this time from the right. Yeah, and it looks like it's also going to 1/2. So the answer to this limit question is 1/2. In example 3, they give us an f of x which is a piecewise function. The top piece is x minus 2, or a line, that lives everywhere except for at x equals 3. So you'll notice if we look at that line, there's a hole or a gap when x equals 3. The bottom piece of this piecewise function says when x equals 3, the y value goes to 6. So this suggests the ordered pair 3, 6 for this point up here. And the inclusion of this point for this piecewise function is going to create a little bit of confusion, so you're going to want to pay attention. The specific question that's being asked is to find the limit of f of x, or find the limit of this piecewise function as x approaches 3. This little piece right here is going to reveal to us where along the x-axis we need to look. So I'm going to go to x equals 3, and I'm going to project an arrow up towards the curve. And what I'm going to do is I'm going to move along that curve to the left, and then I'm going to reapproach that point. So as I get closer and closer, the y values rise and rise and rise until I get to that point, and it looks to me like they're tending toward the value 1. If I go over to the y-axis, it looks like they're going to 1. But I'm not done yet. I need to jump over to the right and then reapproach from the right. Now the y values right now, they look like, if I project over to the y-axis, like they're about 3 or so. But as I move down and approach from the right, they're dropping, 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 and now it looks like they're going towards 1. So if I approach from the left, I go towards 1. If I approach from the right, I go towards 1. So the answer to this limit question is 1. But students are always confused about this dot here. Well, they say, well, what if that dot had been 3, 4 instead of 3, 6? Would that have made a difference? And the answer is no. If the dot were here instead, that's not going to have any effect on approaching from the left along the curve and approaching from the right along the curve. So no matter where this point had been redefined, whether it was 6 or 4 or wherever, for this particular problem, the limit answer is going to be 1. In number 4, f of x is a rational function. It's x squared minus 1 over x minus 1. If you factor the top using difference of two squares, it cancels with the bottom and you end up getting a line that has a hole in it. The specific question says, find the limit of this line with a hole in it, the limit of f of x, as x approaches 1. So x approaching 1, this little statement here reveals to us where along the x-axis we need to look. So I'm going to find x equals 1, and I'm going to draw an arrow up in the direction of the curve. Now I'm going to jump over to the left and then reapproach that arrowhead. And as I reapproach, the y values are rising and rising and rising to a certain number. And now I'll jump to the right and I'll reapproach toward that arrowhead. And now the y values are falling and falling and falling. And it looks to me like they're falling towards this number 2. The answer to this limit question is 2. And the answer is 2 regardless of the fact that there is actually not even a point there. It's not really so much about this specific location, rather what is happening as you approach that specific location from the left and from the right.